In this video, we're going to practice finding z star for any confidence interval. Okay. So we're going to do a few. Let's say first I want to do a 90% confidence interval. Okay, I draw a picture every single time. Okay, so if I want a 90% confidence interval, that means I have 90% in the middle. Well, then you have to figure out what z value is going to give that to you. So we want to figure out z star right here. But my table doesn't give me areas in the middle, it only gives me areas to the left. So the easiest thing to do would be, say, I know I want 90% in the middle, but you could say, well, how much needs to be in this tail? Because then I could find this value right here. So if there's 90% in the middle, well, I could do, let's see, 100% minus 90%, that would be 10%. Well, 10% is supposed to mean both tails, so I could divide that by 2 and get 5%. So I know there's supposed to be 5% in this tail, 5% in this tail. Okay, that's not by memorizing the steps, it's just saying, okay, 90% is in the middle, that means 5% on both tails. So now you want to look for a z value that has 5% in the middle. So the area is where you're looking for the percentages. We're looking for the closest we can get to 5%, which looks like it's going to be about this 4.95% is the closest I can find. So this z value is negative 1.65. And then by symmetry, this value has to be positive 1.65. So if you want a 90% confidence interval, z is going to be 1.65. So we can make a list. So 90%, we're going to use z star equals 1.65. Okay, so we tried that. Let's try something else like 99%. So let's say we want to do a 99% confidence interval. So we need 99% in the middle. Well, how much is that going to leave for each tail? So 99% in the middle, then that means you'd have 100 minus 99%, or 1% for both tails. And then if you do that, so 1% and you divide it by 2, that would give you 0.5% in each tail. So this is 0.5% over here, 0.5% over here. We want to figure out what is this value and what is this value. What are those z values that are dividing it that way? So now look for 0.5%. Looks like we're going to be somewhere about here, somewhere between 0.47 and 0.54. Looks like this negative 2.6 is just slightly closer. So if this is negative 2.60, then z star is going to be positive 2.60. So 99% will use a z star of 2.60. Now if you used 2.55, that's going to be just fine. Your answer should be close enough to still get the correct answer. If you wanted to try and round in between and say like 2.57, great, that's fine. But it's not required. Okay. So that's how you can find z star for any confidence interval. Now, the question that sometimes comes up is, what is this supposed to be for a 95% confidence interval, which is the most common one we use? So you could draw the picture and say you want 95% in the middle. And if you do 100% minus that means 5% total for both tails, or you divide that by 2, and you get 2.5% on each side. Because we had 95% in the middle, and that means you'd have 100% minus 95%, which is 5% for both tails, or 5% divided by 2, which would be 2.5% in each tail. Okay, so we're looking for the z value that has 2.5% area to the left. So the closest one I can find is this negative 1.95, which means z star equals 1.95. So to add it to my list, 95%, we're going to use z star equals 1.95, or we can use 2.0. The reason we use 2.0 is because the book has taught you for so long that 95% of our data will be within 2 centimeters because it's easy to memorize 95% is within 2 centimeters. It would have been a lot harder for you to memorize that 95% is within 1.95 centimeters. So 1.95 is a little bit closer, but we just memorized 2.0. The book will always use 2.0 just because that's what they had you memorize. It's close enough. Again, it's not going to affect your answers. It's just fine. You can use either one. But that's how you can find Z-star for any confidence level, is you always draw the picture, put 95% in the middle or whatever you have, figure out how much is in each tail, and then come find the Z value on the table.